Okay. Testing. And I should get this. Let's put here. Let's put here. This is live. What about this? Okay. Good. And let's open this, because why not? Okay. Can I pop this out? Good. Yeah, let's just put this here or something. Close this. Okay, Jesus, basically rotted in bed all of yesterday. I should get back to it. So there's some stuff I should type up, but instead of doing that, I'm going to venture forth and do a new calculation that should be, Jesus, where did that come from? Should be exciting. Okay. Let's see. So the correlation function here that I want to compute is this. Great. So oh yeah, let's put some music on. So EU5 rather, soundtrack just dropped, and so figured why not listen to this. It's video game music, so I shouldn't get copyright struck, but let's see. What I'm comparing, right? And so there are two regions where this is important. You know. AX and ALK goes to prime. Yeah, and let's put both of these on the boundary, the ADS boundary. happens is this, it's just here we go. There it is. So if these are opposite, then what we get is 2 sinh omega. And then this sets this equal to that. So then I get rid of these. I get a delta function. Two differences. So I should just write omega here. So now you don't have this factor. That's interesting. Oh, yeah, this is supposed to be an absolute value. G is not that one, but rather okay, and now we need to substitute these things. Here we go. No, not that here. So So let's see, let's just talk about the boundary functions. And then here we go. So if you want to talk about the boundary node function, q bar plus q bar minus so if you do comparison So if I swap omega, then this will be q plus and q minus, and this will just get this. But that's basically the same thing. Yeah. Okay, and I also need x plus what would this be? This would be here probably. Okay, so let's copy this. Good, good, okay. And instead okay, good. That's going to be annoying. Okay, let's leave it for now. What is this? Holy shit, why are you using so much memory? Whatever. Yeah, there's just this factor that's missing. Everything else is the same. This song is kind of a banger. Okay. You know, that's fine. Just like ignore it for now, maybe. But then, let's see. This is what you're doing. So this is what you're doing. So let's just substitute. T prime, X prime, K is fixed. Right. Yeah, I should just fucking like do both. Yeah, I should. I mean, it's not that much extra effort. So C to prime K if S is greater than 0. So I should be looking at L and L. For S greater than 0, so it's just this is just C minus K prime minus K minus S. So if S is greater than 0, let's say minus. Okay, and then it's just V of VL of minus K, VL KX and K prime X. Okay, and then I do the integral of these. This will be like C minus. But then for all intents and purposes, this is basically this. And so what one gets is this. Wait, it's important. So here, if S is greater, oh, but there are these factors that but this doesn't matter. Sorry. So basically, this is what it comes down to. And so here S is positive, but it costs to negative S. Second of all, I need to flip all the momentum. This should be fine. Also, I don't flip anything here. I do flip these objects. Oh, this should be N, right? And this S is negative. So it just goes, yeah, that's right. It just goes in the negative direction. So this is it. I just take this and I plop it here. I replace this x with x prime, I guess. That's good. And I flip all the momentum. Good. Yeah, what the hell is this? Kind of mid. Listen to the rest later. What's good? This is always good. Right. Not that. This. And then, so I just flip this, but then I also need to flip S minus S, so that's good. So, okay, let's bring this into main. Okay, so sorry, this should be S prime. So, S plus X 0 S prime and get dressed before you fall. So if this is greater than 0, then there will never be any LR. This will always be 0. Yeah, that will always be 0. So never have to deal with this. I only have to deal with keep breathing. Some point I have to go back. Maybe at some point now. So we are sort of substituting this shit in. And let's call this a different index. Right. Sing us a song to keep us warm. This. Such a chill. Okay. So let's bring this out. Where do I get the pi squared from?
We
That's where I
all
get the pi squared from.
let you choke. Let you choke.
Gotcha. Two of these. Okay. And then let's go back here. This is exactly the same. This doesn't actually play F1. Right. Okay, so so what we do is we start with this. And we change it variables to, you want to do this to factorize. And k plus is omega plus q over 2. K minus equals omega. Great. And then pick up the factors to go from this to this. So let's see. Basically this. Oh yeah, there is a bag here. That's important. I could go up with that for 2 Let's see, so d omega d2, this will be So D will make 1, 1, 1, minus 1. The absolute value of this determinant is 2. D k plus D k minus. So I pick up a factor of 2, and then this factorizes k plus int k minus. Okay. K plus k minus. Right. This should be the same as what's here, except we don't use factors. Oh shit. So very important, there's a plus here. That's also important, that's not here. Good. Okay, so this should be the same thing, just without these guys. And yeah, that's what I want to do is basically not that factor. So if A is above 0, A is bigger than 0, then I want to put H minus. Right. A is greater than 0. Okay, that's a little strange, but okay, so if A is greater than 0, I want to close in the lower half plane. And already used that. Let's use L. Okay, so if I'm closing in the upper half plane, then it should be this. In the lower half plane, then it should be this. A greater than 0, close H minus, I guess. So then just put this here. Good, and now we want the sum, do the sum. We do want to do the sum, right? Yeah. Good. If a is less than 0, if a is less than 0, then that's small. So you want to raise something small to a large power. Good. Now you put this, and then you just flip twice. This is plus, right? So equals okay, so this is the same. Oh, sorry, this is the same in either case. So this comes out, and so is, okay. So now you have to, yeah, okay, so instead of a cinch, you have okay. Yeah, so what you want to do here is you want to do something like that. Okay. And then I want to turn this into basically that. So let's pull out a factor of this raised to this power, or rather this raised to this power, and as a consequence this becomes this. Yes, and this just becomes cosh of 2. Well, 2 cosh of 2. Yeah. And then you have these two. Okay, so here it's kind of a little different. Here you want to pull out a factor of this thing raised to this power. And then again, this is what you get. Okay. So So now what you do is good. What about this? Okay. Yeah. Okay. Okay, and this does not depend on the sign of. This does not depend on the sign of H. Let's see. This is always positive. And then you have A over 2. Yeah. Interesting. Because so this is minus plus, I guess, right? Because when A is greater than 0, okay, this I mean, I confirmed this with, yeah, so this has to be right. It's just when A is greater than 0, that's greater than 1. Wait, is this wrong? That would not be good. Bruh. What if I put in? Okay, so what if I put in e to the pi z here? If A is greater than 0, okay, yeah, God, that scared me for a bit. We'll be back shortly. Oh, what's this? Hello. Yes, anyways. What am I doing? So, this should be right. I should check again. Question mark? Yeah. good. I should check again because, I mean, why the hell not? So this becomes cosh, essentially. So, okay, so closing at h minus, yeah, the 2 pi gets killed with this, and then good. So then what happens is you have you have this, but then you want to bring that out, and so that can be cosh, and then you want to multiply by this, and you have to check if this is the same as these two. Oh, come on. So you just have this, and I want to see if this is the same as this here, and okay, good. And what is this exactly? This is wait, a over 2 minus n over 2. Excellent. So good. And this is note now independent of so need to compute treat a greater or versus less than 0 less than 0 arbitrarily, but result independent unlike BXR prime case, no I epsilons to worry about, and this is likely because, yeah, just not singular. Okay, so we can just keep going. Now we substitute into for later. So, okay, number 1, we have this thing. Okay, so here z is just that k prime. So it's like this is a, right? So if this is a, then I just put this here, and I just put this here, right? Okay, so that's included. So z is just k plus. Good. Yeah, and this just comes along for the ride. Okay, the second integral is this. And now, so z is k minus. And the difference here is now let's take this. Okay, it's quite nice. So this also gets just, you know, thrown away. Well, not thrown away, but good. And now I can simplify this a little. So these two cancel out, and then this gets doubled. Right, just add those two together, and then, ooh, that's interesting. You have square, and then this can just be about here. So So now I have this double sum to do. Yeah, so it's really not too bad. Okay. And so the way to do this properly is you have this raised to the m, and you have this raised to the n. Okay, this stays. Wait, that's kind of sus actually. Something is amiss. Is it? 8. And what was it? The other one? And A11. Okay, so at some point I need to use that formula, but that's okay. So m, you just stick this in here, and Jesus Christ, you stick this in here, and this is t minus t prime. T minus t prime, this goes away, this goes away. When you add the 2, okay, so this would be t plus t prime over 2, right? Because, god damn it. So let's just do this, over to the sign, then that does that. Yes, so then, whoops. That kills this. So you're good here, and now you just have to put this here, and so that does away with that. But then you have to, let's see, the square root, that's fine, that's always positive. And I just have to put you in both of these slots. Excellent. Well, maybe that's a little messy, so let's put you here, and now I need to do a sum. Which is x, y, okay, now I just do m, 0 to infinity, and same with n. And what do I get? Oh yes. This is what I get. Just write it down. Right, okay, so I have x. This is the other way, but it doesn't matter, this is symmetric. A and B. could check this either way, but let's just go to this. Make sure I didn't make any mistakes. Okay. So what is this? Swap those without repercussion. So let's just put this here. Let's just put this here also. Okay, I guess so. Yeah, and see this as so this equals this. X plus y over 2, so this. This. That's not what I want. Yeah. Other way. So 2 minus x minus y over 4, I guess. Okay, so it's important to get that side correct. What? God damn it. I am guarded. So everywhere I have delta, I should replace it by 2 delta. No. God damn it. Here we go. No. Everywhere I have delta, so this is 2 delta. 2 delta. Yes, no, this would be. Okay, good. Now let's put this here. Good. No. So 2 delta. That would make this delta. That would make this delta. And same thing here. Okay, so now here's the key. And now we match. Good. And now we just stick this in here. And what is Z? Z is this. So this is equals this. Okay, are these the same? Well, we should check. What? Oh, and then you do this doubling thing. Okay, I think that's fine. It's just delta. Okay, that's good. That's good. That's confusing. I see. So you, okay. But I'm not gonna use that because, why? May as well. Just to check. Divided by 4 to 2 delta. And then this is which functionally does not matter. Oh, hello. I'm just doing some research. So there's this correlation function that I want to compute. Basically, you have a field. You can think of it like an electric or magnetic field, for instance. And if you like change something in the field at some point, how does that affect the field at another point? So that's the basic idea of a two-point correlation function. The one I want to compute is kind of more complicated. So you're in a three-dimensional black hole background. A black hole is dual to it's dual to like what's called a conformal field theory in one less dimension. So there's this notion of holographic duality where you can have a theory in d dimensions that's dual to a simpler theory in d minus 1 dimensions, and so if you do something in one theory you can kind of get what it is in the other theory. So I want to compute a correlation in a black hole background using the simpler theory. But one of the fields in the correlation function, you do something sort of special to it. You apply this non-local transformation that's generically kind of complicated, but it's cool because when you compute this correlation function, it's not simple, but you can express this in terms of this 2f1 hypergeometric function, and like everything you could possibly care about is known about this 2f1 function. Well, that's not quite true, but a lot is known, and so you can do some cool stuff. Anyways, I think this form is more useful, question mark. But this identity. Nice. Okay. And so now we can just stick it in here. So this is X. This is X, this is Y. And so I can just take this here. And you just add the two. X. This is Y. Everything else you can just ignore. And so now you get something that's kind of interesting. This is the best one. This one. Be very careful. Don't fuck up. Yeah. So this becomes 1/2. This gets killed. Okay, good. So this is the result. Oh, I don't know what this is here. I mean, I can apply some. This reduces to 2pi, which is kind of nice. This gets rid of this, which is also kind of nice. Yeah, just kidding. Doesn't matter. Make it look a little prettier. Basically the same thing. So this factor is not here, importantly, and the cinches get transformed to partials. Oh, that's not good. Yeah, this should be. Okay, and so nice. And then this is basically very similar to this. But S is okay, so properties. Then what you get is just the ordinary left-right correlator. Should be good. This is 0. And there should be an identity for this. Very nice. Let's take a look at this, by the way. Let's go to trig to mask. more properties. So singular behavior. Oops. This is what we've been looking for. Moment of truth. And this thing equals 1. Because if this thing is 1, then yeah, and then this thing, let's simplify this thing. Now what we do is you bring this over here at the expense of a minus sign. And then this square root eliminates you. So we want to do something like this is t minus t prime. This is t minus t prime. And then no. Here, the constant is t plus t prime, this is t minus that stays there. So, we get something like this. So here the t primes cancel each other out. Here the t's cancel each other out. And then get something like this. I want to factor this. I think that's okay. Bruh, okay. How do I want this to work? So what did I factor this as? Let's see. Wait, do I? Kind of confused now. Okay, so I want 1 to be in terms of let's see. Prime. Here it is. The okay, so let's. Multiply by and here let's multiply by the chi prime, and here let's multiply by the chi prime, and so this goes away. Now these just I should not have done that. Come on. Yeah. Okay, what I want is I want to send you here. Do this. Send you here. And I want to also send you here where it kills this. Send you here where this kills this. Okay. So now it's gone. And now chi minus chi I have, and I also have my plus. Okay, and here this is e to the chi minus chi plus, and here it's very similar. Okay, so here I want to multiply by e to the minus chi. I'll kill this. Okay. And now I want to multiply this by Jesus Christ. Okay. Plus, which will kill this. This is what I want. And let's just confirm if these two are the same. Wait, this is not perfect. Where's the root? Minus. Okay, this is strange. But these are the same. Okay, so now I just have to deal with this. Really? Yes. True. So now I want to okay, let's go. Okay. So what is this? This is Right. The R region. So x plus equals e to the t plus chi, and x minus equals minus e to the minus t plus chi, right? At least on the boundary. So yeah, so this is 1 over x plus, and this is minus. This is just x minus. Okay. And what about the L region? I think for the L region, these get flipped, right? Let's just get flipped. The L region. So use change to ADS so yeah, but now x plus x minus in R x plus x minus so where you just like these get flipped, right? This has to be good because instead of getting mapped to that, you just get mapped to the direct opposite of that, the antipode. So no. So minus minus. Right, this is x plus, and this is x minus of this. X prime minus, maybe. This is better. Play with this a bit. Say that e chi equals 0. prime. Let's go. And similarity. So let's say that's prime equals 0. Then you need this, which is very interesting. Wow, it's like the time you need to reach that plus the time you need to reach that. So this suggests that this is very interesting. I mean, this is literally what you expect, right? You can also do the opposite. I want to think of this as a bridge between the right region and the left region. Well, I mean, they're both a bridge, but the bridge goes two different ways. One goes like an N, and one goes like the Russian, E, the character, right? Yeah. Just loops. What does this mean? Okay. I should do the other. I should do this. Do this. Equals. So this is always positive, which is good. So always happens for s is greater than 0. shitting me? So this is a minus. And I want to do something like this, right? T. Okay, something like this. And if I make that minus, that will always be negative, which can never be the case. Yeah, so this has to be positive. Okay, and this is something I want to frame. Okay. Great. Sure. And let's just plot this. Good. Minus log. And I want to put this here. That's fine. Let's just do this and do this. If S is negative, right? That's sort of the idea. Wait. So S has to be positive because this guy is positive, so that means S has to be positive. Yeah, that doesn't make sense. So okay, S goes from 0, let's say, times the root to 3 of these. And then it should start out this. Sorry. Something like this. And then you get, yeah, yes, but I should put a minus sign. Right. Good. Okay, so now it's additional minus since direction flips on. So let's just put this. And now this is the singular locus. Why is this a problem? Let's just take the real part of this. Would that solve my problems? I think that would solve my problems. Oh, but then I need to do this. Oh, that's cool. Okay, so sorry, that's not what I want. I want to do So I use this if condition. Right, I use this if condition, and so if s is less than e to the minus t, then I plot this. Otherwise, something like this. Okay. Otherwise, okay, something is weird. There we go. Otherwise, I do this. Good. That's very cool. Okay. And now I Penroseify. Oops, don't do that. I Penroseify. And how do I do this? Well, it's I think this is fine. I just put this here. And I don't do this. And I just do this. Okay, yes. So let's put this here. So at some point I hit this thing. What happens here? Okay. Oh, I have to, yeah, I have to do this. That's actually very cool. It's very cool. That shouldn't be there. Okay, whatever. Hmm. There's gotta be a better way, right? It doesn't matter. I'm lazy though. No, that's not it. Should do like a circle. Where can I add text? And let's just make the font bigger. Let's just try 48. Okay. Let's go back to this. Okay, so this is very interesting because What does this mean? I think this means I'm suddenly in the... I'm suddenly in the left boundary. I don't know. Should think about it. Okay, I will be right back. Okay. definitely write up these results. And this is really the only way this can be seen. Yeah, that's the only way this could be singular. There are no so the other possibilities, if this is infinite, either this can be zero or this is infinite, this is finite. For this to be zero, that's impossible because cosh is always greater than one. Yeah. That's true. So it would be very useful. It would be very useful. Let's see. Hello, if you're still there. It'd be very useful if I could evaluate this. If W is 1, what's new? That's it would be very useful if I could do this. What if M1 is Right, so this is sort of a solid result that sort of just exists for now. And then at some point I have to take a look at the content base. Then you have some shit like A1, F1, P1, and 2, sorry, K2, K2, B1, N1, B2, N2. That's kind of weird. This is kind of strange, you know. Yeah, this is a little weird. This is a little weird because if you take a look at this, wait, not that. This, and we're computing the sun. I don't really buy that. I see. I think it's something like this. Then you have this squared, and then you have yeah, basically this. two of these guys, and then so weird stuff happens when one of them becomes a 1, but otherwise it's fine. Yeah, so A1 versus N1. M1, sorry, B1. W squared E2 W squared. And weird stuff happens when, yeah. So I think I can do these sums. I can do these sums, no problem. You just got that and now the hope is okay. So let's take a look at this more carefully. Right, and you get 2 of these. And you get those, that kills that. Then you have 1/2 plus n. And then you have, just whatever. You have 1 plus n. And then you have this thing raised to the n. Okay, so now this is something similar. This should be here. This thing is the same. And then 1/2 plus n plus 1 plus n. You have 2 of these. Then you just have that, which gives this. Then furthermore, you Okay, so right. So let's put this here. Let's put this here. Okay. Good. 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 And now this is, yeah. So so yeah, what's the idea? The idea is you take one of these at the boundary. And then you approach. Well, this is something I know. Right? So check, 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 check. Check, check. And it's quite a similar thing we've got here. Half. This one. Half. So now I need to multiply by two of these. And now I need to multiply by this. I have to divide by this. And I have to multiply by this. Over 2, again, not 3 halves. Nice. Okay. And let's do that as well. Just do this. And you can use these couple 4 representations. Delta, 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 delta delta 1/2 A2 okay, so now I just change this, and this stays, unfortunately. Well, it doesn't matter. This thing, now it's just delta. Now it's 3 halves. Now it's A2. Now it's this thing. So check, 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 check. A2, yeah. Okay. So now we just, so, oops. Why is this one singular? This is singular when, square root this. Plus, yes, and so, what you do is you now substitute these results. Okay. What is what? So that I don't care about. Yeah, okay. Jesus Christ. Let's see. A1 equals A1 is raised to the M1 E prime times T. W squared 1 minus W prime squared over 1 minus W squared divided by usage delta C minus epsilon squared. Oh, sorry. Okay, this is actually exciting. So there's C plus and there's C minus. And A2, something similar, except this is flipped. This is W prime. This is flipped. Sinh plus, sinh minus. Okay. And B1 equals now interesting, this is not squared. Two equals this 2 S prime. Yeah, 2 such C. Okay. So, wait, if I said, there should be some metric, yeah, yeah. Now so, double, wait, do I say W or W prime goes to 0? want to keep W prime. I want to keep W prime versus 0. So that means I will do this rather. And it's like much the same. The only difference is I have a 1 instead of a 2. It's much the same. Is the same. This is 1. Okay. So you can plug shit in. So I take W prime to go to 0. So that means this is square root. That does okay with this. Why don't I just do this? I'll just copy this. This gets eliminated. So W prime is 0, right? Yeah. W prime is 0. Delta C plus equals 1/2 delta T plus minus pi plus 1/2 log 1 minus W squared. Let's just take this here. Now I want to control I, E, M, there we go. Okay. So let's do this N. No, this is N1 rather. And this is, I want to take the root of this. If I take the root of this, then this becomes to the 1/4 power. And then something like this. Okay, this is manifestly. Good. So now I need to add B1 plus B2. Yeah, so this is just this minus S. B1 plus B2, but I also need to go off this factor of 2, so that's good. Okay, what is manifestly? This thing is the only negative part. Quarter. So it's, oh yeah, I need to deal with this. So now you just start Jesus. So now you just put plus here, and you put minus here. And that's just the same thing as this. Okay. Let's say there's no. So this just gets squared. If you take this both ways, they're square root. I don't think so. Yeah. I want to do something like this. Whoa. Let's say this one greater than 0. Oops, or S prime equals. Wait, so S, so that's here. And now you're there. No, I want to ask the other question, right? I want to be like, I evolve this, and the question is for what? For what values of that is that singular? This is interesting. This is interesting. So I have one point here is the question I want to evolve. Sorry, that's not it. I have this right wedge, and I want to evolve, so I can evolve both. So the first thing I can ask is I keep this and I make that singular. I think that's less interesting. So this is S prime, this is S. Now I want, sorry, this is W prime and this is W. Well, yeah, S prime, S. So now I want to set S prime equals 0. I finally want to set S prime equals 0. So that means this is just S. This is when this can be singular. Okay. When is this singular? So if S prime. At what point does it hit the singularity? So this is like. Oh. The difference is this gets. What is this? This has to be somewhere. Okay, let's see. One. So I have e to the minus t. Oops. 1 plus w over 1 minus w. Okay, so let's just do this. We'll just swap these things. Swap this thing. So this is v. Okay. And what is this one? This is prime? Is that it? Yeah. So you have this kind of thing, and so let's take this. So this is v, this is u, and this is v, and 1 over t prime. So this is t chi w prime, and this is just t prime, I guess. Yeah, but v is the same as u, so. Okay, this is super interesting. Super interesting. So how long does it take to reach the singularity? This is like. This 0. Here. Yeah. This 1. is this for both values of S prime? This singular. This is obviously positive, so you want to just solve for. So you want to just solve for, yeah. Okay. Plus. So you evolve the same point. Yeah, this doesn't doesn't mean anything. There might be some reduction formulas. A, B. So in this case, it actually reduces to a 2 of 1, kind of. C1 equals B and C2 equals B. And here it also reduces to a 2 of 1. C1 equals A. And C equals A. This is very close, you see. This is very, very close. very close. When delta is large, this should be true except for order 1 constant. B minus A plus 1. So close. So very fucking close. This is very interesting. These formulas are basically all the same. That would be cool if you have something over here, and the question is when does it go into the light cone? Right. I think this is very doable. Yeah, that's very interesting. I really believe that's what it does. I believe it avoids the singularity. If I take a point here. there's something very profound at play here. And I would like to understand it, obviously, but it's quite strange, though. It's quite strange. Boundary to bulk. So bulk to bulk seems difficult. I can't seem to be able to compute anything here. However, I mean, this is the key, right? The new feature, the new insight is, okay, you fix some evolution as parameter and the initial point of the evolved field. Now you ask, with which other points, right? Is it like that if x prime, such that if you have like a field at x prime, then the 2-point function is singular. And the idea is that this can tell you about the support of the original guy. So it's the 2-point function is a probe of support via like micro causality, or just causality. I mean, via causality, because if they're separated, then this should not be singular, right? If they're like space like separated, the only way for this to be singular is if there is a null. Is if there is if they're on the light cone. If they're null separated. Yeah, the only way for this to be singular is if they're null separated. So that means there must be some non-trivial piece that's on the light cone. And so that's one ingredient. Another ingredient is that you can actually compute this boundary to bulk 2-point function, which is neat. Well, at least in terms of these apple and 4 functions, I don't know if Maple can probably plot these. Mathematica seems to have some bugs, but in any case, you have the singular locus, right? And you can actually go. You can actually use the. Yeah, you can just parameterize the singular locus and see for yourself. Okay, this is good. This is very good. Okay, so at some point I should write all this down, starting with what? So there are various where did this go? Here it is. Yes. Let's bring this over. And there are various things that can be said about these 2-point functions. So you have boundary to boundary, boundary to bulk, and bulk to bulk, right? So it's like, okay, well, what can we actually compute? We can compute, so there's boundary, and left boundary and the right boundary, right? There's the left boundary and there's the right boundary. And then there's bulk. There's a left bulk, there's a left bulk, a right bulk, and the future bulk region. And now this is like the similar similar sort of picture. So left boundary to right boundary to right boundary. I know what this is. And this is so this is I want to basically cancel this because if I know what, well, okay, fine, doesn't matter. These are equivalent, so yeah, I can compute everything here. And then it also seems that I can compute the right boundary to the right bulk. That means I can do this, and I think I can also do this. So this is hard. So there are like there are like yeah. So there's the boundary to bulk. There's divider. There's the right, left, future, past, divide. There's the S in different regions. There's the zero, there's the minus infinity to S plus, then there's S plus to S minus, and there's S minus to infinity. Well, there's also S equals 0, which I guess supersedes that. So 2 times 4 times 3 is 24 correlation functions. Wait. Sorry. No. So I need to actually square this, right? So that's 20, not 24 squared, but because some are strictly like greater, some are supersede the others. So each of those 3 are in principle different, and then each of those 4 are, but that's not true. So I should be able to connect big picture. So I want to connect this discussion with the local so omega over Q fixed vector fields. But this is not easy. Okay, let's think. So, I mean, step number one is almost really just write down what I have and make sure I understand each case separately. This is a pretty tall order though, to do all of this. Okay, so small steps, one at a time. It is a Friday. Okay, let's think. And then there's also the difference between, let's see, between compact case and non-compact case. Well, this is a total 2x multiplier. This in principle should be squared. Yeah. So I should make a picture of which calculations supersede which other calculations. I mean, this is stuff that probably shouldn't do right now. Advisor would say definitely don't worry about that now. Yeah, so I should write this down carefully. Okay, so let's do that. But let's take a walk. Let's think about this for a bit.